Okay. So I had a query from one of the teachers in the course. So are you able to view the answers of the already solved or already past assignments? I mean, which have the expired due date. So can you see the solutions of that?
Yes, it's possible to for us to see it. Not
Okay.
the solutions, the answers.
Yeah, I mean, yeah,
Answers
the
are
answers. So that already passed the due dates. So I mean, you cannot submit that. So and the answer should be visible. So that was the query from one of the instructors in the course. So he was asking me. Just I don't know. I don't have the access to the course. What it's the course portal. So I can't say. So you can see the answers, right? So whatever the answers for let's say assignment 1 to assignment 9 or whatever is there. Fine. Because I mean, you have the examination soon, right? So it will be helpful if you can see the answers. Okay, fine. I will just tell him that uh, you can see the answers. You are able to see the answers. Fine. So we will start with uh, today's topic, which is about extreme events. Okay. So now, first of all, let me ask you, what do you mean by extreme events? What what is your idea, your guess about extreme events? Any clue, any idea about what you can call as extreme events? Okay, so forget about extreme events. Think about any extreme value in a set of objects. So let's say you are, um, let's say you are taking a set of people who are running 100 meters of race. Now, some might finish the race in 20 seconds, some might finish in 30 seconds, some might even finish in, that is very rare, but 11, 12 seconds. So among this set of the values, what you can call as extreme values,
when the values deviate from the mean a lot. Like,
right? So
uh,
Anurag, Anurag Bera has the answer, aberration from normal weather and harmful climate change events like cyclone heat waves. Yeah, that is fine in context of weather, but in a more mathematical sense, can you define that? So yeah, Arjun, you were telling deviation from the mean, right? So yeah, I mean it is the deviation from the mean. So if you take any type of distribution, mostly there is a theorem called central limit theorem or law of large numbers in which if you take a lot of samples, the distribution essentially converges to normal distribution, or they also call it as a Gaussian distribution. So it has a mean, it has standard deviation. Standard deviation means where the values or the occurrences start declining. So, I mean, that is, of course, a mathematical definition. So, that is the mean minus the value squared over all the instances and then taking an average over that. So, that is the formal definition. But if you take value from far from the mean in the range far from the mean, then the instances will be rare. So, the probability of finding those instances will be very less. And they are called extreme values. Now, for as Anurag Bera answered, for weather context, aberration. So this is a big aberration from normal weather and harmful climate change events. So heat waves. So normally our temperatures are in the range, let's say 25 degrees to 35 degrees Celsius. But if it exceeds 40 degrees Celsius, then it is far from the normal or the far from the mean value, which is quite a bit of the standard deviation from the mean value. That is in terms of temperature. For cyclone, let's say your normal wind speed is 5 meters per second, maybe 10 meters per second. But for cyclone, the winds may go up to 15 meters, 20 meters, even 50 meters per second. So that is a deviation, a big deviation from the mean. So that is called as extreme event. And in terms of rainfall, let's say in June, July, August, September, there might be 1 centimeter of rain in one day. So that might be called as normal, depending on various regions. So if there is, let's say in one day, there is 10 centimeters of rain, then there will be flash flood. Instantly, there will be flash flood or similar kind of conditions. So that can be called as extreme event. So in mathematical terms, if you take the distribution, big deviation from the mean, probably maybe a couple of 2 or 3 standard deviations from the mean might be called as extreme events. But of course, it is very contextual and depends on the system you are studying. So with that basic discussion, we are looking for the predictability of different extreme events. So here the extreme events are listed here. And on the y-axis, there is the ability to detect the influence of global warming on the specific event. And on the x-axis, what is the current understanding of those events? So it seems that for extreme cold or extreme heat, so very high temperature like heat wave and cold wave like which is a colder temperature, we are somehow able to predict it quite well and we have good understanding. That might be a consequences that might be a consequence of the conservation of energy from the law of thermodynamics, because the temperature will certainly follow the law of thermodynamics quite well. So that might be a reason behind that, and we can predict it well in advance. Then comes the drought event. So that is less than the normal rainfall. If there is no rainfall or very little rainfall over a period of time, then there will be drought. Similarly, the extreme rainfall. So both are having similar kind of understanding, and both form a place in the medium range. So somehow we are able to predict those droughts or extreme rainfall events maybe 1 or 2 weeks in advance. Suppose there is a um, strong high pressure zone somewhere in the upper troposphere, then we can say that there might be drought or there might be very less rainfall over the next few days or next few weeks. Suppose we detect one depression or low pressure area, or might be some shear zone or trough in the ocean or in the sea, and we can somehow track the movement, then we can give the warning that there might be extreme rainfall due to that particular low pressure area or the trough. So these are in the mid range. Now there are different elements like tropical cyclones, extratropical cyclones, extreme snow and ice. That is little difficult to predict. And the most difficult in this case is the severe convective storms. So severe convective storms that might be in a small scale, and that might be in a small scale like tornado also, and that might be little in a little larger scale like local convective storms. I think in South India, in this time there are mango showers, especially might be in the Karnataka or Kerala coastal regions. There might be intermittent showers which are known as mango showers. In the northern India, there might be local winds like I think they call it Lu. So these are also local winds. And in also northeast India, there are local thunderstorms. So these are quite difficult to predict, and we don't have enough understanding about those systems. So, but they fall into the category of the extreme events. Okay? And the predictability of these events depend on the level of understanding we have till date. So we have fairly good understanding of this heat or cool events temperature equation, but we don't have enough knowledge about the convection in the tropical and the extratropical regions. And wildfire is a consequence of this drought or this speed of the wind might be very high wind might cause some wildfires, and it might also help to spread it. So but we don't have enough knowledge about that. So yeah, so that was the just to give some example of the extreme events and how much understanding we have about those extreme events. Now in the climate change scenario, we are expecting that the extreme events or the occurrences of the extreme events will increase. So there might be more fluctuation of these extreme events. So, yeah, so any doubt on this slide?
सर एक बार हिंदी में और समझा दो।
Okay. I'm just trying. So, okay. आपको समझ में आई कि एक्सट्रीम इवेंट किसको बोलते हैं? व्हाट इज द डेफिनेशन ऑफ द एक्सट्रीम इवेंट? तो एक्सट्रीम इवेंट किसको बोलते हैं कि कोई भी जब वातावरण का या कोई भी चीजों का अगर आप कुछ डिस्ट्रीब्यूशन लेते हैं, उस डिस्ट्रीब्यूशन का जो मीन है, मतलब मीन एवरेज जो वैल्यू है, उससे कई दूर वो अ, अगर अगर आप वैल्यू वहां मिलता है, कहीं दूर मिलता है, बहुत दूर, विच इज a few standard deviation away from the mean, तो उसको हम एक्सट्रीम इवेंट बोल सकते हैं। अभी ये वातावरण के लिए लागू होता है कि हीट वेव के लिए लागू हो सकता है, कोल्ड वेव के लिए लागू हो सकता है। ड्राउट मतलब कम बारिश, एक्सट्रीम रेनफॉल मतलब भारी वर्षा, स्नो एंड आइस, बर्फबारी, ट्रॉपिकल साइक्लोन चक्रवाती तूफान, एक्स्ट्रा ट्रॉपिकल साइक्लोन जो एक्स्ट्रा ट्रॉपिकल में चक्रवाती तूफान होता है, सीवियर कन्वेक्टिव स्टॉर्म्स जो आपके हो गया कि अचानक से बादल छा गया और बिजली बरसात शुरू हो गया, इसको हम लोकल कन्वेक्टिव स्टॉर्म्स बोलते हैं। तो इसमें हम वर्णित वर्णित करने की कोशिश कर रहे हैं कि कौन सा घटना को हम कितने अच्छे तरीके से पूर्वानुमान कर सकते हैं। हीट और कोल्ड वेव का जो है वो काफी अच्छे तरीके से अब तक हम पूर्वानुमान कर सकते हैं, क्योंकि उसका स्पेशियो टेम्पोरल स्केल भी काफी ज्यादा है। मतलब अगर बहुत ज्यादा आपका ताप का प्रवाह या ठंडे का प्रवाह होता है, वो हम कुछ दिन पहले ही निर्णय कर सकते हैं। ड्रॉट और एक्सट्रीम रेनफॉल उतना अच्छा नहीं कर सकते, पर फिर भी हम बता सकते हैं कि अगले एक हफ्ते तक बारिश कम होगा या फिर एक हफ्ते में बहुत भारी वर्षा की संभावना है, ये हम बोल सकते हैं। पर ये जो चक्रवाती तूफान का उतना अच्छा तक अभी तक उतना अच्छा जानकारी है नहीं हमारे पास। हालांकि पिछले 20 सालों में हमारा काफी आगे बढ़े हैं हम। और सबसे ज्यादा मुश्किल होता है कन्वेक्टिव स्टॉर्म्स जो होते हैं, मतलब अचानक से जो बादल छाया हुआ रहता है, या फिर मतलब वायु का जो ऊपर ऊपर की तरफ, ऊपर की दिशा में उसका जो चलन होता है, उसके लिए जो तूफान पैदा होता है उसको कन्वेक्टिव स्टॉर्म्स बोलते हैं। तो उसके लिए हमारा जानकारी बहुत कम है, और हमारा ये प्रदर्शन करने का यही मकसद है कि हम बोलना चाहते हैं कि जो अ, ये जो धरती का जो वातावरण का परिवर्तन हो रहा है, ग्लोबल वार्मिंग, तापमान बढ़ रहा है, इसके लिए ये सब एक्सट्रीम इवेंट का संख्या भी बढ़ने वाला है भविष्य में। और संख्या के साथ साथ उसका जो प्राबल्य प्राबल्य का भी वर्धन होने वाला है। ओके।
Yes, ma'am.
ओके, सो द नेक्स्ट I have a few questions on the extreme events, so it might be good if you can just interact. So, can you just tell us that what are the qualitatively changes in the number of extreme events for geological, meteorological, and hydrological event? I will just repeat it in Hindi. So, geological मतलब भूतात्विक का जो परिवर्तन है, उसके लिए आपको extreme event का क्या प्रभाव पड़ेगा, number of extreme event. Meteorological वातावरण का, hydrological मतलब जो पानी है, पानी का जो चक्र है, उसके साथ क्या बदलाव आएगी। सो कैन यू जस्ट गेस how many extreme events, what can be the qualitative change of the number of the extreme events for first geological changes? Any idea? Geological means let's say plate tectonic activities or whatever happening with volcanoes, etc. So can you guess that?
The earthquakes are increasing, right? So is that
Earthquakes are increasing, so that is, yeah, Anurag Bera answer. Geological earthquake. Yeah, it is one of the part. Earthquake is of course one of the part. But see, the earthquake is completely controlled by the plate tectonics, which is an internal matter of the earth. So as it is controlled by plate tectonics, it has nothing to do with the climate change, because climate change
no?
deals with the atmosphere and let's say the hydrosphere, that is the ocean and the atmosphere. Okay. So there is no correlation between the number of earthquakes. It might be, people might be confused. So people have a notion that the earthquakes are increasing, but it is not related to climate change. Okay. So it has complete correlation with the plate tectonic activities, but not the climate. So the number of extreme events due to geological changes will be mostly constant, at least at this time scale. One thing can you say that if there is something, let's say if there is some volcanic eruption, due to that, how much fire will spread, how much weather it can change, that will have some impact, because the weather itself is, the climate itself is changing. But solely solely due to the earthquake or solely due to the geological activities, the number of events will not change, the number of extreme events, because earthquake is an example of the extreme events for geological activities. Okay. Next, meteorological. That you can easily answer. How much you can, how much, or not how much, just asked qualitatively, not quantitatively. So what can you expect for meteorological perspective? Let's say the temperature. What is your expectation about the temperature in case of the extreme events? तापमान के साथ क्या हो सकता है आप बता सकती है थोड़ा.
The temperature will increase due to global warming.
Fine,
So,
that's fine. The average
that
temperature
will,
will increase, right?
yeah, average temperature, yeah.
So, but what will happen to the extreme values?
So, yeah, as temperature increases, the atmosphere can actually hold more water vapor, so there will be more precipitation.
Okay,
So, extreme rainfall will
right,
be there.
right. So temperature increase will cause, in general, more rainfall, or the holding capacity of the water vapor in the atmosphere will increase. And due to that, the number of heat waves will also increase because the mean temperature is increasing. It means the extreme value of the positive end, I mean the heat wave
Oh, okay.
values, that will also increase. The number of cold waves, that will probably decrease because it is shifting from colder to warmer scenario. Okay. But there is a small catch, that is, we studied that the Atlantic Meridional Ocean circulation. So for global warming, temporarily the Atlantic Meridional Ocean circulation might be weakened. That might bring a little span of cold weather conditions in regions like Europe
Europe.
or America, North America, like that. But that might be temporary. By the way, I just read in some discussion that the Antarctic ice is also having some hefty amount of contraction, and that is also, I mean, a big concern for the Atlantic Meridional Ocean circulation. So Antarctic is also being affected highly. Okay. So yeah, and hydrological. Any idea about the hydrological events?
The number of flash flood will be increasing. Flash
Yes,
flood.
yes, yes, yes. Number of flash flood will be increasing. That is a consequence of the heavy rainfall. And also, that is a consequence of urbanization, because in urban areas, if the roads are very concretized, then the water cannot penetrate into the ground. So the number of flash floods, that is, the water is flowing through the above the layer of the soil, so that will also increase. That is the consequence of the hydrological event. And also, there might be more droughts in the hydrological sense, because there are many rivers which are fed by the glaciers, but due to climate change the glaciers might be shrunken. So that might provide irregular water flow. So that is also another possibility. If due to some reason there is a heat wave, then people will be in trouble. Okay, so the next question is a very informative one. So mention a few countries that suffer from extreme weather events. So our neighboring countries, Myanmar, Bangladesh. Dominica is in the Caribbean Sea, I think. Haiti, Honduras, and yeah, of course, our country is also suffering because they suffer from the tropical events, especially heat waves. We are suffering more from the heat waves, also from the cyclones, and also from the flash floods. In 2013, we saw flash floods in the Uttarakhand region. I think in 2022 or so, we saw big flash flood in Pakistan also. So these tropical regions are heavily being affected due to the climate change. And in Myanmar also there is irregular rainfall activities. And also some storms, some cyclonic storms are heading towards the Myanmar coast. Fine. Uh, okay. Next question. Uh, yeah, that is just a mathematical or just intuitive question. Any distribution has constant mean, but the variance increases. What does it denote to the occurrences of the extreme values of the distribution. So, Ankit, Mukesh, can you answer that? You have a distribution, probability distribution, that is a collection of events, let's say, and you have the constant mean. So the average value is constant, but the variance increases. So do you know the meaning of the variance or so the
Measure of
variance is increasing. Now what will happen to the extreme values?
increase. Okay, so variance is the measure of how much deviation occurs
Right,
from the mean, right?
right,
So if variance increases, then there will be fatter tails.
right.
Probability of extreme
So
events will
variance
increase.
increases means there is more variation apart from the mean in a literature sense or in a crude sense. If there is more variation,
Yes.
then of course there is more chance that the extreme values will appear frequently, more frequently. So the extreme values will also occur more frequently. Okay. Mm. Okay, next question is okay. Ask this to Ankit Mukesh. I will first tell in English and then. So why in general a smaller animal has higher chance to withstand warmer climate? जो जानवर छोटे होते हैं उसका गर्मी सहन करने का क्षमता ज्यादा होता है. इसका कारण क्या है? Can you tell it, Ankit Mukesh? Any guess? Any idea? Think about the size of the animal. Think about the surface area. Think about the volume of the animal. From that, can you try? Idea? Okay. Anurag has some idea or not?
Sir, surface area will be more if the animal size is less. So surface
Surface
area,
area will be more or surface to volume ratio will be more?
surface to volume ratio, like nanotechnology, like nanoparticles, the
Yes, yes,
surface
yes, yes,
volume, it will be
yes,
this, uh,
sure.
will be more. So if the animal size is low,
Right.
then uh, then it will generate its own heat that
Okay.
will be distributed in the surface, so it can withstand the out like the environmental temperature
No, I
more.
mean, what is the mechanism for generating heat? How, what does it depend on? Does it depend on surface area or does it depend on volume? The heat generated.
It depending on volume, like
Yes, yes. It depends on the volume because it basically depends on mass and mass is the density times the volume, but let's say the density is constant. So it essentially depends on the volume. More volume means more energy generated. Okay,
hmm.
now continue.
Now if the volume is less,
Right.
so um, mm, uh, like
So you have you have higher surface area compared to the volume. So you have
yes,
generated some amount of energy, but you have greater surface area for small animals. Then how is the heat dissipated? What is the mechanism of the heat dissipation? Is it through volume or surface area?
heat dissipation, generally dissipated, like the when the heat is dissipated, this will be proportional to the surface area.
Right,
Mm. So if the surface area is increasing, the dissipated heat will be also increasing.
right.
So it will be able to withstand the environmental
So the cooling mechanism will be more efficient in smaller
more efficient,
animals,
smaller
right?
elements. Yes.
That's why it will be able to withstand more heat. Is it clear to everyone?
So,
So,
Yes. Yes.
okay. That is a actually that has a very basic physical understanding, as Anurag Bera mentioned about. You studied nanotechnology, right, Anurag Bera? So you mentioned about that.
Yes, I have studied nanotechnology, so
Ah,
they also this
so can
like
you just explain what is the, I mean, because we're not expert about nanotechnology, so what is the methodology used there to utilize
like,
this?
they say that when the surface area is and volume ratio will be increasing, then
Right,
the particle will be when the particle will be small size, then the surface area and volume ratio will be increasing. That
right.
will be helping the particle to act more efficiently on any surface.
Okay, okay.
Similarly, here if the animal size is lower,
Right.
then the surface area to volume ratio will be also increasing. So that will be also efficiently working on surface.
Okay, okay.
And here,
So, okay, so the similar concept is used when you use powder for chemical reaction. If it is in powder form
yes,
rather than the
yes,
solid form, reaction
yes,
will
yes,
be quicker, right?
yes, yes,
That's okay. So this follow the similar argument. So the surface to volume ratio that plays important role in many aspects. Okay, this is just one example. So that's why there was an instance of the Maasai tribes in Africa. So they are using goats instead of the big cattles to carry those different different burdens or different goods for their purpose because the goats are able to withstand more heat. Okay, so the next question is about forest fire. Okay, mention a few causes of forest fire. So this was, I mean, just informative, so not much things are there. The human negligence is the uh, major cause of the highest number of forest fires happen due to this human negligence, okay? Because humans leave their, what I would say, the fires or let's say some burning substances, or they forget to douse the fires. So that's why a lot of forest fires happen. Also, sometimes due to natural causes, lightning, due to volcanic eruptions, and due to the rubbing of trees, especially when the area is very dry, then the winds can act and somehow, if there is some friction between the trees, which can produce some spark that can lead to forest fire, and that can lead to small fire which with the help of the strong wind can take massive or very gigantic form the, the whole forest. Okay, next question, mention the two factors that is increasing the sea level due to global warming. So the question is, why is the sea level rising due to global warming? So any idea about that? Ankit Buka, shall I repeat in Hindi or is it fine?
रिपीट करते जाओ सर साथ में।
ओके, तो अगला सवाल है कि समंदर का जो स्तर है वो क्यों बढ़ रही है ग्लोबल वार्मिंग के कारण। ग्लोबल वार्मिंग के द्वारा क्या हो रहा है ऐसे, जैसे कि समंदर का स्तर, समंदर का ऊंचाई बढ़ रही है। इसका जवाब आप दीजिए। I will come to Anurag Bera. No idea, Ankit Mukesh? Or you want to say something? Actually, there are two factors. दो कारण है. Okay, Anurag Bera, you can just tell one of the factors.
so the melting of glaciers due to climate change.
Okay, now let me just clarify one thing. So there are ice sheets present in the ocean also, ice sheets present in the land also. Which one do you think is contributing to the sea level rise? तो जमीन में भी आइस शीट मौजूद है और समुंदर में भी मौजूद है, बर्फ का जो बर्फ बर्फ का जो शीट जो है, तो उनमें से कौन सा का अवदान हो रहा है यहाँ समुद्र का स्तर वर्धन होने में, ये आपके पास सवाल है. So yeah, which one is contributing to the sea level rise? There is a subtle difference, okay, between land ice and sea ice.
So this is land ice, I think.
Okay, you're correct, but can you explain why it is land ice? Sea ice, so sea ice is not contributing to the uh, raising of the sea level. Why? What is the cause for that? So I would ask you to do a simple experiment. Do one thing. You can everyone can do it. I think in just 5-10 minutes, whenever you get time. Take a glass of water and take a glass of water and put some ice into that, and then see how much the water level. So there will be some level of water, right? Because the ice is also submerged and the water is there. And after the complete melting of the ice, just look how much height, how much height it has been increased. Okay. So note the initial height of the water, note the final height of the water after the ice completely melts. Now, our logic is that as the ice is already submerged in the water, due to the Archimedes principle, it will actually
Displace the water.
displace some amount of water. That will increase the height of the ice compared to the no ice situation. But after it melts, the displaced water will be compensated by the melted water. So that is our argument. Then just for this sake, try the experiment at home and see how much the water level changes. Then you will get your answer. And land ice is always increasing because it is an extra ice. So initially there was no ice and initially there was no water. Finally, there is water from the land. That's why the water is entered into the ocean or sea. That's why the sea level is rising. So mm, that is the clear answer for the land ice, of course. But for sea ice, I would urge you to do the experiment. Ankit Mukesh, what I was telling is आप एक ग्लास में थोड़ा बर्फ डालिए, मतलब पानी डालिए, उसके बाद थोड़ा सा बर्फ का कुछ टुकड़ा डालिए और पहले ऊंचाई कितना हुआ है पानी का वो आप नोट कर लीजिए। उसके बाद बर्फ पिघलने के बाद कितना पानी का ऊंचाई है वो भी नोट कर लीजिए। दोनों में कितना अंतर है वो देखिए। ये ओशन आइस और सी आइस की तरह काम करता है। ओके, तो तब आप समझेंगे कि सी आइस का कितना अवदान है पानी का जो ऊंचाई वो बढ़ाने के लिए। ठीक है, कैन यू डू दिस एक्सपेरिमेंट? Just try this. Okay. Okay. And a second reason is that as the global warming is occurring, the temperature of the ocean, temperature of the sea is also increasing. And you know, if you apply temperature to solid, liquid, or gas, it has a thermal expansion coefficient. So the volume is some initial volume times 1 plus some coefficient, let's say it is gamma times the temperature increase. Due to that, if you apply any heat to any substance, but please don't apply the heat to water from 0 degrees to 4 degrees Celsius because it contracts from 0 to 4 degrees Celsius. Just apart from that, if you apply heat to most of the substances, it will have volume expansion. Same happens to the water of the ocean. It will have volume expansion. For that reason also, the sea level is rising. Okay. So there are twofold reasons. Of course, the main reason is the land ice. And this is secondary reason.
Like you mentioned, the water will contract right from 0 to 4 because of anomalous
Yes.
contraction.
That will contract for 0 to 4 degrees Celsius, but that will be applicable in the polar regions.
Okay.
Not in the
So for Arctic,
major,
Arctic and
Arctic and Antarctic regions, not for the majority of the oceans. Yeah, water has a special property because it contracts from 0 to 4 degrees Celsius because the liquid structure somehow is more compacted from 0. It is most compacted at 4 degrees Celsius. And 0 degrees Celsius at ice it forms some crystal structure which takes more space. So the density decreases. So from 4 to 0, it is basically increasing its volume. An exception.
okay.
Okay. Okay, just let me tell it in हिंदी. So पानी को जब आप गर्म करती है 0 से 4 डिग्री से बाद, आप वहाँ का अभी थोड़ा आलोचना हम चर्चा नहीं करेंगे उसके बारे में, पर 4 डिग्री से ऊपर अगर तापमान होता है तो पानी का जो वॉल्यूम, आयतन आयतन का वर्धन होता है. आयतन अगर वृद्धि होता है तो उसके लिए भी ऊंचाई, समंदर का ऊंचाई बढ़ सकता है. तो ये दोनों कारण हैं. एक है लैंड आइस जो पिघल रहा है, पिघलने के बाद वो समंदर में मिल रहा है तो उसके लिए समंदर का ऊंचाई बढ़ रहा है. दूसरा कारण है कि तापमान बढ़ने के कारण इसका जो आयतन है वो भी बढ़ रहा है, उसके लिए भी समुद्र का जो स्तर है वो थोड़ा ऊंचा हो रहा है पहले से. तो दो दो तरीके का कारण है. ओके, नेक्स्ट आई विल शो यू. Okay, I will just show you this picture for describing the extreme events. That is the effect of the extreme events for the global warming. Now here you can see that the gray color shows the initial position or the current climate, and the black solid line shows the future climate due to global warming. Now the distribution will have change in the mean or the change in the average temperature. So it moves towards the hotter climate. And while it moves towards the hotter climate, it will experience more hot weather or extreme weather in heat wave regime. But it will experience less cold weather or extreme cold weather. So in general, we can expect more heat waves in the future time. Okay, that is the consequence of the temperature for the global warming. But there are different consequences of different phenomena. Let's say the wind might have different consequences. The wind might have more extreme values like more cyclones, more tornadoes, this type of things. The precipitation will also have extreme values. So there we can expect more precipitation in short amount of time, because due to the increase of the temperature, the holding capacity of water vapor in the atmosphere will increase. So when it will start raining, it will have the capability or the potential to rain more, to give more rainfall to a particular region. Now, okay, now let's come to the heat waves. That is the special kind of our extreme events. We will be discussing a few words about that. So heat waves or extreme heat is a period of abnormally hot weather and natural disaster that lasts for multiple days, might be a few weeks also. So that is the definition varies across different nations, different countries, but in general it is defined by the more than the temperature which is more than the normal by few degrees. In India, I think the definition is for 4.5 degrees or 40 degrees Celsius. If the temperature is more than 40 degrees Celsius and also above normal by 4.5 degrees or more, it is called heat wave. In Europe or in USA, the definitions will vary. But in general, it is just excessive heat, excessive temperature. ताप प्रवाह, आई एम जस्ट टेलिंग इन हिंदी पर. ताप प्रवाह सामान्य रूप से कई ज्यादा तापमान होने से संज्ञायित होता है. विविध देशों के लिए यह संज्ञा विविध तरीके से परिवर्तित होता है. तो ये जो तापमान, ये ज्यादा तापमान कई दिनों से 1-2 हफ्ते तक रह सकता है, और इसका कारण है हाई प्रेशर एरिया इन द अपर ट्रोपोस्फियर. तो ज्यादा दबाव वाला क्षेत्र अगर पैदा होता है ट्रोपोस्फियर के ऊपरी भाग में, तो ये पैदा हो सकता है. सो इट इज जनरली कॉज्ड बाय द लॉन्ग लास्टिंग हाई प्रेशर एरिया. सो व्हाट हैपेंस इज व्हेन देयर इज हाई प्रेशर एरिया, then there is downdraft, and downdraft gives dry air. If the dry air is there, then it cannot rain, and if it doesn't rain, then the solar radiation instantly is trapped within that particular region. If the solar radiation is trapped within that particular region, then it will concurrently increase the temperature for a few degrees, and it might reach extreme values. So that is the main reason for the heat wave. After the high pressure area is removed by nature, then we get relief from the heat waves. And the consequence of the global warming, as we can easily guess, that there will be more heat waves with longer durations. And the peak temperature of the heat wave is also becoming higher. So ताप प्रवाह इसका संख्या भी बढ़ेगा, इसका जो मान है मतलब सर्वोच्च तापमान का जो मान है वो भी बढ़ेगा, ये विश्व का जो गर्मी बढ़ रहा है उसके लिए. It is usually possible, it is a good thing that we can predict heat waves might be a few weeks ahead to take appropriate actions. तो इसका पूर्वानुमान करना उतना मुश्किल है नहीं. As we saw in the first slide that the extreme hot and extreme cold events are relatively easy to predict. Okay. But there is another thing which I will also illustrate. We will also see that combination of high temperature and high humidity can cause moist heat waves, which is very dangerous compared to the dry heat waves. In a moist heat wave, the body cannot properly cool because there is more moisture in the atmosphere by the sweating or the perspiration mechanism of our body. We cannot cool. Okay. हमारा जो शरीर में जो पसीना होता है उस वो क्या करता है, हमारा तापमान को नियंत्रण करता है, क्योंकि पसीना जब वाष्पीभूत हो जाता है तो उससे हमको ठंडाई मिलती है. पर अगर वायु में जो वाष्प का परिमाण वो ही काफी ज्यादा है तो पसीना सही से वाष्पीभूत नहीं हो पाता, उसके कारण हमारा जो शरीर है वो भी ठंडा नहीं हो पाता. सो दैट्स व्हाई द ह्यूमिड or the moist heat waves are far more dangerous compared to the dry heat waves. In the dry heat waves, we at least can cool with the mechanism of the sweating. But with the climate change, the temperature is also increasing, the humidity might also increase. That's why the possibility of the moist heat waves will also be higher. So that is a matter of concern. And especially regions in India where we can see dry as well as wet seasons, the possibility of moist heat waves is increasing rapidly. So that is a very deadly phenomenon of the atmosphere. Okay, so let me just see the chart. In this chart, we can see that there are temperatures written in Fahrenheit. Okay, so it is a little difficult because I picked it from the weather.gov and it showed the temperatures in Fahrenheit, but the basic concept will remain the same. So let's say the temperature is 80 degrees Fahrenheit, the relative humidity is 40%. The effective temperature or the real field temperature will be 80 degrees Fahrenheit. Now, if the humidity increases to let's say 90%, then the real field temperature will be 85 degrees Fahrenheit. Now, this is for the temperature which is 80, which is pretty low. 80 is not a high temperature. 80 means 80 degree Fahrenheit means how many Celsius? I think 80 minus 32 by 9. So that is I think 48 by 9. I think 5.5. So it is around 25 degrees Celsius or so, let's say. So it will not affect much. But if the temperature is, let's say, close to 98, which is our body temperature, 98 means 36 degrees Celsius. So if it is here, then we can see that even 40% of relative humidity can increase the apparent temperature up to 105 degrees Fahrenheit. And if the humidity is 70%, then it is 134 degrees Fahrenheit. So it is a real massacre if the humidity is higher. And they have not basically mentioned the values here because beyond this range, the death of a human is confirmed, mostly confirmed. So human cannot survive in that region, the red region. Okay, that's why the humid heat wave is a very dangerous phenomenon, and with the climate change, it is becoming a central matter of concern. Okay. Okay, any question on humid heat wave? Anurag Bera asks, Sir, can we get the PPT you are showing? I will share the slides after the class in the link where we all can see in the Google Drive. There is a link. After the class, I will just send the PDF there. Okay. So any questions on the humid heat wave?
Yeah, actually, at 100% relative humidity, condensation will occur, right? So, will that affect the apparent heat felt by a human body?
What is your question?
No, at RH is equal to 100% condensation will occur, right? So, will that affect the temperature felt by a human body?
If condensation occurs, then you are basically telling that there is rainfall. And rainfall, the raindrops always have lower temperature compared to the environment. But we are talking about the relative humidity at the surface, not at the
Oh,
upper
okay, okay.
troposphere. The condensation occurs at the middle or upper troposphere. So
Is it like fog?
it is like
Fog is
it is like fog. But if it is like fog, then it will not bring any relief, because the temperature will be just as high as the temperature of the surrounding. So it will not bring anything new. And the heat, even if there is some release of heat due to the latent heating, that heat will be within the surface itself. It cannot go anywhere else. If it is raining, then the heat is released in the upper troposphere or middle troposphere, and the colder water droplets fall into the onto the surface. So that's why rainfall cools down the surface, but it warms the middle troposphere or upper troposphere. But here we are talking the relative humidity exactly at the surface, and we are not taking into account the condensation.
okay. Thank you.
So that is the point. Okay. Next, temperature of India. Okay. I think in your assignment you have to determine the number of heat wave days, or which state is being affected most by the heat wave, looking at their given problem in the assignment. That you have to do independently. But just to read through maps, we have just put this slide from IMD and Indian Meteorological Department, and from there we will basically um, look what was the temperature outlook for 2025 April. That is just 1 year before. And the left panel shows the maximum temperature, the right panel shows the minimum temperature. So in the left panel, you can see there is so I have to zoom in. Let me zoom in. Yeah. So here you can see that in the central India, Chhattisgarh, Maharashtra, Telangana, Odisha, Jharkhand, Gujarat, there's some parts of Rajasthan also, some parts of Andhra Pradesh and Karnataka also, you can see a high possibility of above normal temperature. So I suppose these areas experienced heat wave in the month of April 2025. And another phenomena is there, and other states are relatively cool, but they will take the temperatures well above normal. So most of the states were actually above normal, but these states experienced severe conditions for the heat wave. Now here is another concept which is about the minimum temperature. If the minimum temperature is above normal, then it will not be called as a heat wave, but it will be called as a warm night. So there will be discomfort at night about due to less sweating or increased temperature. So if the minimum temperature is quite above the normal range, then it creates disturbance in really human activities. So that is another feature of the climate change. So the minimum temperatures will also increase, or in other words, the night will not be able to cool down as much as before. Just to read from the graph. Here you can see in Uttar Pradesh, Bihar, Jharkhand, in Rajasthan, also in Punjab and Haryana, and also in Gujarat, Madhya Pradesh, Maharashtra, also in also in Kerala, so and Tamil Nadu. There are warm nights you can see. So the possibility of higher minimum temperature was quite increased in this time period of April 2025. So it was taken from the press release of the Indian Meteorological Department. Okay, so here we will just discuss about the sea level rise. That is the effect of the global warming, and they have plotted the sea level rise during the 21 years from 1993 to, sorry, it is 30 years, right? So 31 years. So 1993 to 2023. And it has increased up to 20 centimeters at a few regions. And at coastal regions, it can show changes of up to 10 centimeters. So 10 centimeters means 0.1 meter. But the coastal areas are in real danger due to the sea level rise. There are some associated dangers also, but this is the primary danger due to the sea level rise. It is also expected that certain regions, for example, the certain countries like Maldives might go underwater in the next few decades. So there are assumptions, there are predictions on that. Also, a large portion of our lowland regions like that Gangetic Delta and also lower regions of Gujarat might go underwater in the next few decades. We just are not discussing about the cities like Japan and China. They are also lowland, so they might also go underwater. So there is another effect which is caused by land subsidence, that is uncontrolled extraction of groundwater. If the excessive groundwater is extracted from the alluvial plains or the surface of the ground, then it creates a lot of pores in the ground, so the ground slowly subsides or comes down from the normal level. I will just explain in Hindi. So here यहाँ क्या हो रहा है कि यहाँ दिखाया जा रहा है कि पिछले 30 सालों में कैसे समुद्र का स्तर का वृद्धि हुआ है। बहुत सारे जगहों में ये वृद्धि होने के कारण जो तट के किनारे में जो जगह नीची जगह है वो डूब जाएंगे समुद्र के नीचे। और इसके साथ और एक प्रभाव भी है, वो है कि हमारा जो पानी निकलवा जाता है जमीन से पंप के द्वारा या फिर जो भी हो ट्यूबवेल के द्वारा, तो उसके कारण दब जाता है ये ग्राउंड नीचे, जो धरती है वो नीचे दब जाता है, क्योंकि वहाँ जो सरफेस के नीचे पानी का बहुत सारा स्तर, सरफेस मतलब मिट्टी का बहुत सारा स्तर होता है, तो वो स्तर में जो पानी संचित रहता है उसको हम निष्कासित कर रहे हैं। उसको निष्कासित करने के कारण उसका जो अंदर का जो शून्य स्थान पैदा होता है, उसके कारण वो धीरे धीरे दब जाता है। वो जो दबने का जो परिमाण वो काफी ज्यादा है। ये ग्लोबल वार्मिंग के कारण जो दब रहा है उससे भी, तो नीचे जा रहा है उससे भी, तो ये एक बहुत बड़ी चिंता के कारण है। इससे कारण जो जहाँ से बहुत ज्यादा परिमाण में पानी निष्कासित किया जाता है वो जगह काफी जोखिम में है। नाउ we will talk about the extreme rainfall. Before that I will just okay, fine, recordings fine, okay. Now we will just talk about a few consequences of the extreme rainfall. So first of all, what is the cause for extreme rainfall? So due to climate change, the temperature of troposphere is increasing. Temperature of stratosphere actually is decreasing, but we are not dealing about that. So because most of the water is situated in the troposphere, or water vapor is situated in the troposphere. So as a consequence of the Clausius-Clapeyron equation, I am not exactly stating the equation, but do you know about Clausius-Clapeyron equation? What it talks about. I have also not prepared for the exact form of the Clausius-Clapeyron equation, but what is the form, what it talks about? कोई अंदाज है? अंकित, मुकेश जी?
The max.
ये क्लासेस ओवरऑल होता है सर, ये जलवाष्प के मिश्रण के रेशियो को बताता है।
सही सर्वाधिक कितना जलवाष्प संचित हो सकते हैं वायु में, है ना? फाइन।
और फिर
Is it the
यस प्लीज।
ये जो टेम्परेचर होता है सर उसके साथ फिर तेजी से आगे बढ़ता है।
राइट राइट राइट, सही। तो ज्यादा तापमान का मतलब क्या हुआ? ज्यादा या कम जलवाष्प संचित होगा? ज्यादा तापमान के साथ ज्यादा जलवाष्प संचित होगा। यस अर्जुन, यू वर टेलिंग समथिंग।
Is it the maximum amount of water vapor that an air parcel can hold?
Right, right.
Easily?
This is called the saturation water vapor. So maximum water vapor is basically the saturation water vapor, and the amount is known as that follows the Clausius-Clapeyron equation, and this is an exponential form. So I think
As temperature increases, I think saturation, the amount of water vapor also increases.
right, right.
The
So
and
right, and yeah, you're telling something. As the temperature increases, the saturation water vapor increases, and it follows a form of kind of the equation can be roughly given as, though this is an approximation. So the saturation water vapor is some constant times exponential of minus b. Let's say it is a e to the power minus b by t. That is the form where t is the temperature and a and b are constants. So let's consider the factor e to the power minus b by t. So if t increases, then b by t decreases, but e to the power minus b by t again increases. So the maximum capacity of the water vapor, or that is known as the saturation water vapor, that fraction again increases with respect to temperature.
actually, is B negative? B is negative number.
No, b is positive.
Only the okay.
That is just one form. I mean, there are approximations. Actually, Clausius-Clapeyron equation comes from the first law of thermodynamics. And using the first law of thermodynamics, there is application of the second law of thermodynamics also. When there is phase change between water and vapor or any two substances, you can equate the Gibbs free energy of these two substances. And by equating those Gibbs free energy, you have to, I actually forgot the calculation, but using that calculation, you can deduce the form of the saturation water vapor. You have to assume that at saturation, the water vapor and the water will be in equilibrium. So the energy, Gibbs free energy change between the water and the vapor will be equal. And using that, you can deduce the form of the water vapor, saturation water vapor. Okay. Okay. Ankit Mukesh, you wanted to say something?
अब आ गया सर समझ।
ओके ओके। तो आप ये जो गणित के रूप में जो प्रकाश है ये समीकरण का ये पढ़ती है, या आप बस इसका विवृति ही आपको पता है? I mean, if you know the mathematical form or you just know the state, that's anyways, it will not matter. Here we will just discuss with the consequence. So that is with temperature, the mixing ratio will again increase, and that basically leads to the more amount of water vapor into the air. So if there is more amount of water vapor into the air, then if it rains, it will have more amount of water vapor or water droplet to precipitate. अगर उसके अंदर ज्यादा भाप या ज्यादा वाष्प संचित है, तो वो बारिश के समय भी ज्यादा बारिश पैदा करने का क्षमता रखेगा. So that is the reason for heavier rainfall or extreme rainfall. The thing is, the rainfall cannot happen uniformly. So if it could happen uniformly, then we would be out of concern. But it doesn't happen in nature. If there is increase in water vapor, then the rainfall will not be equally distributed in all types of rainfall. So there might be the cases that if there is more water vapor, there will be more splash of rain, more intensity of rain which will precipitate out together, because it has the power, it has the capacity to rain it all. Okay. And consequently, the regions of which are already dry might also become drier. So there is also possibility of dryness. So there is a famous saying with, uh, I mean, in a joking sense, we just say that in the current world, the rich become richer, the poor become poorer, and due to the climate change, the dry become drier, the wet become wetter. So that is just a joke. I mean, you don't take it seriously, but yeah, that is a saying. Okay, now just we said that the short spells of heavy rain, so स्वल्प समय में भारी वर्षा उसका संभावना बढ़ जाएगा, तो यही हमारा दुश्चिंता का कारण है। अगर वर्षा बहुत जगह में एक ही समान रूप से बढ़ता था तो चिंता का कारण नहीं है, पर समान रूप से नहीं बढ़ रहा है, तो कहीं कहीं वर्षा कम हो रहा है, कहीं कहीं काफी ज्यादा हो रहा है, तो ये हमको तबाही पैदा कर सकता है, और यही सारे दिक्कत का कारण है। Okay, but we will now come to the urban areas where the permeability of the ground is lower. Why? Because the urban areas are more concretized. The roads, the houses, they have very little portion of the ground, or I mean, basically the little portion of the surface of the earth or surface of the ground layer of the earth. So if it rains, there will be very little space for the water to pass through the ground into the underground circulation. Okay, that's why in the rural areas the water can penetrate the ground, but in urban areas the shorter spells of large water flux will not be able to penetrate through the water, through the ground, and it will cause a surge or flood like event. बाढ़ आने का संभावना अर्बन एरियाज में ज्यादा है, मतलब शहर के जगहों में ज्यादा है, जो गांव है उसके तुलना में, क्योंकि शहर के ज्यादातर जगह में आप कंक्रीटाइज रास्ता या घर जो भी हो वो कंक्रीटाइज्ड है। कंक्रीटाइज्ड होने के कारण जो पानी वर्षा के कारण बरसते हैं वो नीचे मिट्टी के अंदर जाने का उसको मौका नहीं मिलता, और मौका नहीं मिलेगा तो पूरा पानी ही ये जो सरफेस है, सरफेस के ऊपरी भाग से ऊपर का जो हिस्सा है वहां से बह जाएगा। तो वो अगर पूरा ही ऊपर से बह जाए या ज्यादातर हिस्सा ही ऊपर से बह जाए तो ये बाढ़ होने का संभावना भी ज्यादा है, पर समय मतलब थोड़ा सा समय में ज्यादा पानी चला जाएगा। जो जगह गांव में है वहां फिर भी वो समान रूप से बंटित रहेगा, मतलब जो पानी है वो नीचे भी जा सकता है और थोड़ा हिस्सा ऊपर से भी जाएगा। तो यही अंतर है rural areas or urban areas. That's why urbanization is not a good planning for this, for competing those climate change issues. Anyways, but there are some risks of the extreme rainfall. The cascading effects that include dangerous flooding, landslides. Landslides means जो भूमि का जो वो स्खलन होता है, भूस्खलन, उसको लैंडस्लाइड बोलते हैं। डिग्रेडेड वाटर क्वालिटी आवश्यक, तो पानी का गुणमान काफी घट जाएगा। पब्लिक हेल्थ रिस्क, शरीर का भी काफी अवनमन होगा। Risks to infrastructure and economic stability would also increase. That these are just the consequence of the extreme rainfall, or let's say any extreme event, because we are habituated to normal, and all our economic policies, all our social structures are built on those mean state or the average situation of the weather. We are not prepared for anything extreme. So anyways, extreme events will cause damages to our current state. Just check. Okay, any questions on this? Is it okay?
Yes, sir.
Yeah, it's fine.
Okay. This is just a slide describing how does climate change affect the rainfall intensity. So that is the normal circumstance warm water, and it rises to form, it forms vapor and then rises and then falls as rain. For every 1 degree Celsius, that is the main thing. Even if you don't know the mathematical form of the Clausius-Clapeyron equation, you can take a very quantitative measurement. That is, for 1 degree Celsius, it can hold 7% more water, and that might cause heavier rain, and that might cause flash flooding. So that is the effect of the extreme weather condition due to climate change. Okay, here we have just mentioned a few more extreme events. For example, the intensity of tropical cyclones will increase. So can anyone say why the intensity of the tropical cyclones will increase due to global warming? चक्रवाती तूफान का जो ताकत यानी कि वायु का जो वेग वो बढ़ जाएगा, उसका कारण क्या है ग्लोबल वार्मिंग के साथ? So what is the
Due to
source?
higher temperature, the ocean, there will be more water vapor, so more energy will be supplied to the cyclone. Is it?
Yes, so you have to consider what is the reason for the formation of a cyclone. That is basically the circulation due to convection. Due to the convection, the water vapor rises into the troposphere, and then the water vapor then condenses, and then the circulation from a side that again enters the cyclonic center. So that is a convective cycle where from the center the water vapor goes upward, and from the side regions or the axial regions, the cold air is displaced towards the center of the cyclone. Now, if there is more temperature, then the amount of water vapor that will be convected in the upper troposphere will increase, and that determines the strength of the cyclone. That's why the strength of the cyclone will also increase. So global warming will basically support the strength of the cyclone. Anurag Bera wanted to say something. You can say now.
So the same answer, like circulation, like in the surface temperature will be higher.
Right.
So that is why the moisture, the atmosphere moisture will be higher.
Right.
And in this way, that the cyclone, the intensity of cyclones will be more dangerous or more higher.
Right. So if we talk about the power of a cyclone or energy of a cyclone, that is driven by the moisture updraft. If the moisture updraft is higher on or the strength of the convection is higher, then we can call it as a strong cyclone. That's why the strength of the cyclone will increase. But we cannot say anything, at least from the model study, we cannot say anything about the number of cyclones. So that is debated. Though people initially thought that there will be more number of cyclones due to the global warming, now it is a matter of debate, because in the last few years we have studied, or not we have, people have studied the number of cyclones in the Bay of Bengal or the Arabian Sea, and we did see any steady increase of the cyclone. So it was almost maintaining an average value. So yeah. Ankit, Mukesh, you wanted to say something? No? Okay. Okay, so next, the heat waves. Of course, we have discussed about the normal heat waves or the extreme heat. Along with that, another thing is becoming famous, which is known as marine heat waves. So that is the sudden increase of the temperature in the ocean or seas. So that affects the livelihood of the sea or the marine region a lot. So that might cause serious problems to the marine animals because they are habituated to certain value of the temperature or the certain constituent of the water that will change due to the excessive heat, the ocean or the sea. And another consequence is the increased temperature will decrease the soil moisture because it will dry up the soil due to more evaporation, and drought events will also increase at different areas. Flood areas also will increase because it will impart irregular heavy rainfalls. So, and as a consequence, landslides also fine. Okay, there's indirect effects, of course. There will be socio-economic effect for these extreme events. That is quite obvious. Okay, now we will go to the monsoon. So, any doubt on the extreme event? If you have any doubt, you can just ask, because we will be just starting a few slides on monsoon, Indian summer monsoon. Okay, no doubts. Fine. Okay, now let's start the monsoon. So, I will ask you the question at the first place. Can anyone say the cause of the monsoon? Why does monsoon occur in Indian subcontinent? It occurs at a lot of places like Africa, North America, also in Australia also. But what is the cause for Indian subcontinent?
So, in general, monsoon occurs due to the differential heating in of the land and sea,
Okay,
like
land sea
like the
contrast of temperature.
yeah, contrasting of heating.
Okay,
That is like the pressure created is different, and along with that, the winds moves from sea to land, bringing the moisture,
so
and also
yeah.
and in this way the monsoon will
So
come.
basically, you are telling that it is a special case of the sea breeze, right? Well,
Yes, yes.
in general, also in the coastal areas, I don't know where are you from, but in coastal areas, I think Arjun might experience that. In coastal areas during the evening or night, there is nice sea breeze, right?
Yes, yes, that's true.
So, according to Anurag Pera, the monsoon is a greater edition or larger collection of this sea breeze that spans across India, right?
Mm.
Okay. Yeah. So, yeah, it was a popular theory till long. And people used to think that it is a basic land sea contrast of temperature, and the land is heated up more. That's why there is a low pressure system, low pressure area over the land, and the sea doesn't heat up. It doesn't increase its temperature much due to the heating because it has higher heat capacity for water. That's why the high pressure is made in the ocean, and the wind flow is basically from high pressure to low pressure. But that theory is not applicable because there are several reasons for that. In school textbooks or everywhere, we are taught about this. So we have the wrong notion of monsoon. So just think about that. When is the highest temperature in Indian subcontinent? It is in the late May or early June, where we can see a lot of heat wave activities. But the monsoon onset is in June, and after that it continues for 4 months: June, July, August, September. After once the monsoon has entered, then of course the heating contrast, the temperature contrast between temperature differences between the land and the ocean decreases, but the monsoon continues. So the land ocean contrast might describe the sea breeze or some instantaneous phenomena, but it cannot describe the large scale circulation for 3 4 months. That is the first point. Second point, if the land sea contrast is applicable, then why doesn't it occur at the Arabian Peninsula? Why doesn't it occur at the Sahara region? Why doesn't it occur at the Kalahari region? Why doesn't it occur at the Great Australian Desert? These areas have even higher contrast between ocean and land. If it was the case, the ocean land differences in the temperature, then these areas would have experienced stronger monsoons. But these areas typically don't experience monsoon. There is a monsoon in the African region, which is known as the West African monsoon, but the extent is just below the Sahara Desert. It doesn't reach the Sahara Desert. And the third point is, if we take strong or weak monsoon years, strong monsoon years mean that the particular monsoon year had a very good rainfall, high amount of rainfall, and weak means it had a low amount of rainfall. And if we plot the temperature differences between the land and the sea, then we will see that the strong monsoon years have lower temperature difference and the weak monsoon years have larger temperature difference. And if we just draw two time series of land sea temperature and monsoon rainfall, we will also not be able to find any correlation between the land sea contrast temperature and the monsoon rainfall. Another point is just to add the highest rainfall in August, which can be considered as a central or core month of monsoon that occurs over the sea and not on the land. So these are a few points which suggest that monsoon is not only a phenomenon due to land sea contrast. It might be able to locally trigger the monsoon, but it is not applicable on such a large scale circulation. Okay. So are these points logical? Do they seem logical? Ankit Mukesh, is it fine or I shall explain in Hindi?
Yes, sir, fine.
Fine. Huh? So what is your take on this? Do you think that monsoon is due to land sea contrast or it is due to something else, some larger phenomenon? I suppose you are confused because yeah, we are also taught since childhood that monsoon is due to land sea contrast, but evidences show that this is not due to land sea contrast. Something else is responsible for that. And actually, it is a matter of research. You know, people have uh, studied the solar insolation and they try to describe monsoon using different theories. For example, the solar insolation slowly passes, I mean, the maximum point of the solar insolation, maximum latitude of the solar insolation, it is now in, let's say, 5 degrees north or so. It will slowly pass towards the north, and at June, it will be highest at the 20, 23 degrees, 23.5 degrees north or so. So uh, this will affect the value of the pressure or the value of the wind pattern or the uh, structure of the wind patterns in different regions. And then there will be effect of the topography, there will be effect of the land sea distribution. Together, taking into account everything, we will see the manifestations of monsoon in different regions. Okay. So yeah, so that is the current accepted theory, and this is not due to land sea contrast. Now, in this case, we have just shown the summer monsoon onset in different regions. So the first monsoon onset region of India is in Andaman and Nicobar Islands in 22nd May. After that, the first mainland onset is in over Kerala, and it is around 1st June. So after passing through Kerala, it covers the whole northeastern states and slowly progresses northwestward. And the entire country is covered around 8th July, where it reaches the Rajasthan at the latter stages. And after that, it also starts withdrawing in September. And by the end of October, the monsoon is completely, southwest monsoon is completely withdrawn from the country. Though in the regions like Tamil Nadu and southern parts of Andhra Pradesh and also some parts of Kerala, we see northeast monsoon, but that is a different system. We are just focusing on the southwest monsoon. Yeah. जस्ट चलिए हिंदी सो यहाँ हम दिखा रहे हैं कि जो वर्षा का आगमन विविध जगह में कौन से समय में होता है। अंडमान में 22 में, केरल में 1 जून और पूरा देश को ही 8वें जुलाई तक वो अतिक्रम कर लेता है। इसके बाद सितंबर के महीने में, सितंबर के बीचों बीच या थोड़ा अंत की तरफ ये प्रत्यावर्तन करना शुरू करता है और अक्टूबर के अंत में ये पूरा भारत से ही प्रत्यावर्तन करता है। उसके बाद उत्तर पूर्वी दिशा से भी मौसम का आगमन होता है, पर हम उसको यहाँ धार्य नहीं करेंगे क्योंकि हमारा मकसद है कि यहाँ दक्षिण पश्चिम का जो मौसम है उसके बारे में चर्चा करना। Okay, so here are some questions on Indian monsoon we will discuss. Now, the extent of Indian monsoon is quite high. So you can see that here it is up to 30 degrees north. But in the African region or American region, that is quite less. What is the reason behind that? The main reason is that there are tall mountain ranges like Himalaya, Karakoram, Hindu Kush, which can block the air from the Central Asian region. And if it blocks the Central Asian region, then the wind flow from the south of India that can freely travel towards the mainland of India and also till the foothills of these mountains. That's why the extent of the southwest monsoon is quite high in Asian region compared to the African and the American region. In these regions also monsoon occur, but the extent is not that high. It is mostly 15 degrees north. In Australian regions also, the extent of monsoon is not so high. I think it is again 15 degrees south or so. Just in Hindi, हमारे भारत के जगह में ही जो वर्षा होता है उसका विस्तार काफी ज्यादा होता है और बाकी जगहों में उसका विस्तार ज्यादा नहीं होता। भारत की जैसा जगहों में 30 डिग्री तक हम मानसून का विस्तार देख सकते हैं और दूसरी जगहों में 15 डिग्री नॉर्थ या साउथ तक विस्तार होता है। इसके कारण है हमारा हिमालय, काराकोरम, हिंदू कुश जो पर्वतों है, वो पर्वतों के कारण जो उत्तर एशिया या फिर अभ्यंतरीण एशिया का जो हवा है, ठंडे हवा, उसको वो अटक देता है, रुद्ध करता है और उसके लिए हमारा जो दक्षिण पश्चिम मौसम जो वर्षा है, वर्षा का वायु, वो सही तरीके से विस्तार लाभ कर सकता है। Now the second question is, which air circulation actively controls the strength of the South Asian monsoon? There is another circulation apart from, you know about Hadley cell, Ferrel cell, etc. So, how many of you know about Hadley cell, Ferrel cell? Polar cell? Okay, fine, no problem. Just I wanted to say that this Hadley cell, Ferrel cell, or polar cell, they are मेरिडियनल सर्कुलेशन। तो ये जो चक्र चलता है वायु का, ये मुख्य तौर पे लैटिट्यूड बराबर होता है, नॉर्थ टू साउथ, बट देयर इज अनदर सर्कुलेशन, और एक वायु का चक्र चलता है, उसको कहा जाता है वॉकर सर्कुलेशन, which exists over the Pacific Ocean. I think we have a picture. Yeah, we will show the picture. So here the Walker circulation is from east to west. Or here the temperature is higher, so there is more evaporation, more updraft, and that air goes towards the top of the troposphere, and it subsides down towards the eastern part of the Pacific. यहाँ गर्मी ज्यादा होने के कारण ये जो वायु है वाष्प है, ये ऊपर की तरफ जाता है और पूर्वी तरफ जाता है, पश्चिम की तरफ भी एक शाखा है, उसको हम नहीं दिखाए हैं, और यहाँ पहुंचने के बाद ये ठंडे होकर इसको नीचे पतित होता है और इसके बाद फिर से ये चक्र पूर्ण करने के कारण ये फिर से पश्चिम की तरफ बढ़ता है. Okay, so that is known as the Walker circulation, and that controls the strength of the monsoon. If it is stronger, then there will be more evaporation or updraft in this region. तो यहाँ से ज़्यादा वायु ऊपर की तरफ जा पाएगा तो ज़्यादा वर्षा होने का संभावना. If it is weak, then the Walker circulation, due to the weakening of the Walker circulation, the rainfall in this region will also be lower. And these are also controlled by the phenomena known as El Nino and La Nina, in which the Walker circulation is weakened or strengthened. For El Nino, it is weakened. For La Nina, it is strengthened. एल नीनो के समय में ये कमजोर हो जाते तो बारिश भारत में कम होने का संभावना रहता है. ला नीनो के समय ये काफी मजबूत हो जाता है ये सर्कुलेशन, तो इसके कारण यहाँ वर्षा ज्यादा होने का भी संभावना रहता है. संभावना रहते हैं, हम पूरे गौर से नहीं बोल सकते कि होगा ही, जस्ट अ प्रोबेबिलिटी. ओके. Okay. Next question is, what is the effect of global warming on the seasonal cycle of the average monsoon rainfall over India? So that is a modeling study, and we have seen that, or that is a basically a statistical study. So we have seen no significant changes of the average monsoon rainfall over India. There might be slight changes in the pattern of the rainfall, but the average rainfall over India has no significant changes. Okay. Next question is, what can be the effect of sulfate aerosols in the monsoon rainfall? because स्ट्रेटोस्फीयर में हम सल्फेट एरोसोल या ऊपर ट्रोपोस्फीयर के ऊपरी भाग में सल्फेट एरोसोल डाल देते तो क्या होगा बारिश के ऊपर. So the answer is the sulfate aerosols mainly cause cooling because they reflect a lot of radiation or they scatter a lot of radiation. ये ठंडी कर देता है वातावरण को. Therefore stabilizing the atmosphere. If the atmosphere cools, then it is more stabilized compared to the warm atmosphere, because in the warm atmosphere there will be more possibility of convection. In the cool atmosphere there will be less possibility of convection. If there is more cooling of the atmosphere, then it will be stabilized. If it is stabilized, then the convection will be weak and rainfall is expected to decrease due to that. तो बारिश कम होने के संभावना है अगर स्थितिशीलता, जो वातावरण का जो स्थितिशीलता वो ज्यादा हो जाए, तो वहाँ परिचलन या दूसरे तौर पे वायु का ऊपर जाना, उसके बाद बादल पैदा करना, बारिश करना, ये सब घटना संख्या बहुत घट जाएगी. Next question is, what are the primary controllers of the monsoon rainfall on the time scale of 100 to 1000 years? Just note the time scale. ये 100 से 1000 साल के अंदर क्या नियंत्रण करता है मौसम के समय वर्षा का परिमाण को? Solar insolation and water vapor are the main factors. So solar insolation means what is the solar constant, what is the amount of power received from the sun, सूरज से कितना रोशनी या कितना क्षमता मिल रहा है, and water vapor in the atmosphere, वायु में कितना परिमाण वाष्प मौजूद है, उसके ऊपर भी निर्भर करता है कि कितना बारिश होगा या बारिश का चरित्र कैसा होगा. Next question is, how many days can we surely forecast for the rainfall in India, let's say? The answer is 3 days. We cannot forecast anything accurately for more than 3 days. We can get forecast for more than 3 days, but these forecasts have less confidence. तो कितने दिन के लिए हम पूर्वानुमान सही से कर सकते हैं? उत्तर है कि 3 दिन. अब तक का जो तकनीक है, मतलब व्यवस्था, आज तक का जो व्यवस्था है, सांप्रतिकतम व्यवस्था, उससे हम 3 दिन तक पूर्वानुमान कर सकते हैं. उसके बाद हम सही से नहीं बता सकते हैं, पर उतना आत्मविश्वास नहीं है. Okay, so any doubt on this slide? This were on the Indian monsoon. कोई सवाल? Any doubt? Okay, shall I proceed? I think, yeah, I think I have the last slide because we have just described the Walker circulation. So it is connected to El Nino, La Nina, and the strengthening of the Walker circulation will bring more rainfall. The weakening of that will give us less rainfall. That is typically the case for less rainfall. The case is for El Nino, and for more rainfall, the case is for La Nina. Though there is a correlation, there is no exact relation between these two phenomena. So yeah, if there is El Nino and El Nino, so we can say that there might be less rainfall, and if there is La Nina, we can say there might be more rainfall during Indian summer. So, and these actually control the temperatures of the East Pacific and the West Pacific also. So, if the East Pacific is warmer, it is called the El Nino. If the West Pacific is, I mean, warmer means warmer compared to its normal temperature, of course. West Pacific is always warmer because of trade winds or the natural consequences. But if it is anomalously warmer, then it is known as El Nino. If it is anomalously cooler, then it is La Nina. Yeah, but that is a coupled atmospheric ocean. Okay, so in the last slides, we will just for completion, we're just showing the primary crops and rainfall in different regions of India. So yeah, from this picture, we can see the rainfall in different regions. For example, this Gujarat or Rajasthan and some parts of Punjab and Haryana that receive the least amount of rainfall, which is less than 500 millimeters. The highest rainfall is found in the northeastern states as well as the west coast of India, comprising West Maharashtra, West Karnataka, and almost most of the places in Kerala. And we have some intermediate rainfall everywhere else in the Indian region. And of course, we have the desert here, so the rainfall. Due to the less rainfall, the desert has formed. And now there are crops because due to the global warming, the rainfall pattern will change. Also, crops, the selection of the crops has to be changed because otherwise the crops will not give us good yield or adverse conditions in the rainfall and temperature also. So in eastern India we have rain-fed rice as the primary crop. In regions like central India, West India, we have coarse cereals, and at scattered regions we have pulses, and we have also oil seeds at different regions in our country, and cotton is mostly found on the west coast of western India, also some parts of the Maharashtra and Andhra Pradesh, Telangana, this regions. So what happens is due to climate change, we have to be prepared for selection of the crops. Otherwise, our yield, our production will decline due to the climate change or the change of the climate pattern, change of the rainfall, temperature, etc. in Indian Peninsula. So yeah, so any doubts about uh, this monsoon chapter or this slides on monsoons because it was the last one. कोई सवाल कोई शक कोई सवाल you can just ask. Okay, then any general doubt about this week's lecture or any general question on climate change? If you have any, you can just ask.
Actually, how do we calculate evaporation transfer flux in Lewis model?
News model.
Evaporation transfer flux in Lewis model. How do we calculate?
Okay, so the model I don't know what model you're talking about.
Lewis model, where there is albedo, simple two-layer
Oh, okay,
model.
okay. Okay. So you're talking about the correction to the Lewis model. So where is evaporation flux, right?
Yeah, how is that calculated? How do we know that value? How do we calculate that value? That is all.
You're talking about the instrument measurement of the evaporation flux. Uh, Maybe I don't know exactly.
Is there any equation to derive it, or is it solely based on instrument?
I think no, they calculate it using some parameterization that I know, because the temperature difference between the surface and the layer till which the evaporation is going on. So the evaporation flux is dependent on the differences between the temperature. But for parameterization,
Okay.
what is the constant they put? I don't know. But let me just search for this. I really don't know the answer. Just give me a Google search. Calculate the evaporation in a atmosphere. Evaporation flux, basically. Evaporation flux in
Flux.
atmosphere. Check. Okay. Yeah, some parameterization there is. It is calculated by measuring the rate of water vapor transfer from a surface to atmosphere. Empirical formulas based on Dalton's law. E equals to C times ES minus EA. Okay, so they will consider the saturation pressure, water vapor pressure at the surface and the air vapor pressure, which is at some particular level of the atmosphere, and also the wind speed. Using this thing,
Okay.
they will use the formula A equals to A plus BV times ES minus EA. So if there is more wind, then there will be more evaporation. If there is more difference in the saturation water vapor pressure, then there will be, of course, more evaporation. So that is the empirical. So I don't think they can only use the values pressure deficit, wind speed, and temperature. But I don't think there is, we cannot put the instrument in the free atmosphere, right? That is very difficult. And we will also
Yeah,
not
that's
get the total information. For precipitation, we can get some convective heating. And for precipitation, I think we can use the clouds as the proxy, and also the satellites can measure some amount of precipitation, because uh, the microwaves cannot pass through the water, right? Or some part of the
yeah.
infrared. So satellite might be useful, but evaporation is practically, I mean, the water vapor is practically invisible to the radiation. So that's why they have to calculate using the empirical formula, right? Using this,
V is a vertical wind or horizontal like wind
not
speed.
not vertical, it is horizontal.
Okay.
Because vertical wind is in the range of, it is 100 times weaker than the horizontal wind. So it will not have much effect.
Okay.
Wind speed, yeah, because they are using bulk aerodynamic formula. So bulk aerodynamic formula uses the wind speed at the surface of Earth. Okay, yeah. So they're using like U9. U9 is the wind speed above the ground. So it is the horizontal velocity or horizontal speed above the 9 meters above the ground. Yeah. So many things are empirically derived. So evaporation rate also in models they derive using the empirical formula. So they take it proportional to the wind speed or something like.
Thank you.
Okay.
Thank you.
Any other doubts? Okay. Ankit, Mukesh, is it fine? Anurag, is it fine? Any doubts?
Yes, sir.
Okay. Nikita, is it fine? You have any doubts?
Sir,
No, I am just asking Nikita Kaushik if
okay.
she has any doubt. Okay. If you don't have any doubts, then I will just conclude today's session, and we will meet
Sir,
next. Huh?
so one question, in the week number 11,
Yeah.
the assignments were given, and there was also one practice assignment. So it was told that that practice assignment will not be go for evaluation.
Okay.
But can we expect that the practice assignment, the question may come from that in our final exam also?
Yes,
Like,
yes. I mean, if there is some practice assignment, just practice through that. It is given for similar type of questions. Might not be exactly equal questions,
yeah.
but just practice that.
But sir, those questions are like not MCQ kind of like or mathematical questions, only theory based questions are like that.
Oh, okay. So yeah, in your final examination or the examination, you will be asked to do MCQ or short answer type questions, right? So
Mhm.
there might be subsets of the or some fraction or I mean, portions of the questions which might come into the examination. So it is better to practice that. Suppose you practice a bigger
Yes, sir.
theory and from there smaller parts are there, they might ask you from the smaller parts of the bigger theory.
Okay, okay. Sir, one thing like in the assignments, the assignments were given. There we have to evaluate the data, and we have to evaluate the data kind of like integer data was the answer kind of things. So in our final exam, will the questions maybe in the same type, or will be the MCQ theory based questions?
So you're asking the in assignment there were numerical questions.
Yes, sir, mostly the numerical questions. Yeah.
Mhm. Yeah, I think
So
the format is of MCQ, right, in the final examination.
Yes, yes, that's what in the form it was written that it is multiple choice questions. I don't think there is numeric. I'm not sure, but I don't
Okay.
think.
okay, yes,
But if you have any particular doubt, then you can use the Google forum for asking that doubt because the
okay.
question papers are said by the instructors, and
Mhm.
mm, I am here just to take the tutorial session on the weekends to clarify the doubts. The doubts on
So,
the subject matter.
so will there be any more session before the exam?
So the last session is there, right? I mean, the Friday session, the next Friday, we will have the last session of this course.
Thanks.
Yeah. Because it is 11th week and the next week will be 12th
Yeah, it's the last one.
session. Okay. So if you have any doubts, you can ask, or otherwise we will close today's session. Okay, fine. So see you next Friday if you don't have any other doubts. Thank you for attending today's session.
Thank you.